Hey everybody, this is Miss Moran and this is Unit 9, Video 4. We're going to be working on writing equations in standard graphable form. Because we've only covered our circles and our ellipses, those are the ones we're going to be working with today. And then a couple videos from now you'll see one on hyperbolas and eventually we'll see one on parabolas as well. Let's go ahead and get started on this. So I'm going to go ahead and remind us what our standard graphable form is going to look like. I'm going to add that word graphable, because it makes it very easy to graph from this form. And we start with our circle, which is x minus h quantity squared plus y minus k quantity squared equals the radius squared. And we know that h comma k will always be our center and that r is the radius. So if I'm given this example here, x squared minus 6x plus y squared plus, oops, that should be 8y. Then we're going to go ahead and set equal to 6, that we need to be able to create these perfect square quantities that we have up above. So in order to do that, we're going to be completing the square. But because we have both an x quantity that is a quadratic and a y quadratic, we will be completing the square twice. So we need to separate both of our x's and our y's. So I'll have x squared minus 6x separated from y squared plus 8y equals 6. In order to complete the square, I need to find the constant that I will be adding to each of these quantities. So I'm going to put a plus a blank in here. And because I have 2 blanks on the left, I will be adding 2 blanks to the right side in order to keep the equation balanced. On the left-hand side with our x quadratic, I will take half of the middle number and square it, and that's the process of completing the square. So I'm going to start here and I'm going to take half of this number, so b divided by 2, and I'm going to square it. So half of that is negative 3 squared is 9. Whatever I add to the left side, I have to remember to add to the right side of the equation. I'm going to repeat the process here with the y part. So I'm going to take half of this number and I'm going to square it. So 4 squared is 16. So I'll add 16 to the other side. Now I'm ready to actually form my different squared quantities between the x's and the y's. So this is going to leave me with x minus 3 quantity squared plus y plus 4 quantity squared equals, and then I will sum these 3 numbers here. So that's going to give me 25 plus 6 and 31. So I know that I have a circle that is centered at positive 3, negative 4, and has a radius of the square root of 31. Let's go ahead and try the second quantity, or the second example. For our second example, I have x squared plus y squared plus 10x equals 9. I need to group my x's together and my y's together, but I notice that I only have a y squared. If you only have the quadratic term, it already is a perfect square, so I know that I'm okay with that. So I'm going to have x squared plus 10x plus y squared equals 9. Now the only blank spot, the only part I have to complete is right here with the x's. There is nothing to complete with the y's. So I'll only be adding one quantity to both the left and the right. I'll take half of the 10 and square it, adding 25 to both sides of the equation. So in order to complete the square here, I've actually done the job and I'm ready to write it in this graphable form. So I will have x plus 5 quantity squared plus y squared equals 34. This leaves me with a circle centered at negative 5, 0 and a radius of the square root of 34. All right, so that's what it looks like when we're writing our circles in standard form. Let's try ellipses. So before we get going, let's start with a reminder of what our ellipse looks like in standard form. Our ellipse will be x minus h quantity squared plus y minus k quantity squared, but each of these is going to be divided by the distance that we're moving away from them in order to find our vertices and our covertices, and this is set equal to 1. So, once again, we're going to have to separate both our x's and our y's. But as you notice here, my x quadratic term and my y quadratic term both have coefficients. So I'm going to have to work with those a little bit differently than I did when I had my last examples, which were circles. So I'm going to start by separating them, getting 3x squared plus 6x And I'm going to leave a space. Plus 4y squared minus 24y, leaving a space, equals negative 3. But before I'm allowed to fill in the space to complete the square, meaning taking half of b and squaring it, I'm going to have to factor out the 3 from both of these terms. And then I'm going to factor out the 4 from both of the y terms. And on the left-hand or the right-hand side, I need to add 2 blanks. However, because this quantity here inside of this parentheses is being multiplied by 3, I'm going to add 3 times a quantity. And then right here, I've got this blank, but this one's being multiplied by the 4 because it's in that set of parentheses. I'm going to have 4 times a quantity. Now let's go ahead and fill this in. I'm going to grab a different color so you can see what I'm writing. I'm going to take half of the 2 and square it. Half of 2 is 1, 1 squared is 1. So I'm going to put the 1 over here. So I'm actually adding 3, which is what I'm doing to this side because the 3 would be redistributed. Then I'm going to take half of the negative 6, which is negative 3, and square that. So I'm adding 9. On the left-hand side, I'm going to have 3 times the quantity of x plus 1 squared and 4 times the quantity of y minus 3 quantity squared equals, and then over here I'm going to go ahead and simplify this to be negative 3 plus 36, and it equals 36. Now since this is not completely in standard form, I have one last step, and that is to divide the entire equation by 36. This is going to leave the equation set equal to 1, and it's going to leave me with the denominators telling me how far I need to move away from the center to find both my vertices and my covertices. And that's the next step. So we're dividing everything here by 36, and this will leave me with x plus 1 quantity squared over 12 plus y minus 3 quantity squared over 9 equals 1. So I have an ellipse centered at negative 1, positive 3, where you're going to move in the x direction the square root of 12, both left and right, and vertically you're going to move up 3 and down 3 to find the vertices and the covertices. We're going to try one more together. All right, example number 4. All right, I made a mistake here again. Let's already go ahead and change that before you write it down. It should be 8y. And we're going to go ahead and separate our x's and y's, which will be our first step always. I'm going to grab the red again. So I will have 5x squared minus 20x, and separate that from the y squared plus the 8y, and that equals, positive 4. Make that positive 4. All right, I do need to bring the coefficient 5 away from the x and factor that out, leaving me with 5 times x squared minus 4x plus a blank spot. But then I realize that there's nothing here on my y quadratic term to factor out, and that's fine. So that means I don't have to worry about an additional multiplier. Equals 4, and then this time I'm going to have 5 times a blank spot, but the other one is just going to be a simple blank. So this is for the x portion. When I take half of negative 4 is negative 2, and I put 4 in there, I'll write 4 on the other side. When I take half of 8 and I get 4 squared, I get 16. So notice the difference between the x part, which had to be multiplied because of the 5 on the outside of the parentheses, and the y portion in this case that did not get that extra multiplier. So just be certain that you're aware of when to have that multiplier and when not to. All right. This leaves me with 5 times the quantity of x minus 2 squared plus y plus 4 quantity squared equals, and let's simplify, we get 4 plus 20 plus 16, or 40. And I'm going to have to divide the entire equation by 40. And that leaves me to reduce the first quantity to x minus 2 quantity squared over 8 plus y plus 4 quantity squared over 40 equals 1. I have an ellipse that is centered at 2, negative 4, and in the horizontal direction I'm going to move the square root of 8 both left and right, and in the vertical direction I'm going to move the square root of 40 up and down from our center. The last thing I'd like to remind you here is to recognize the difference between when we have an ellipse and when we're solving for a circle. So when we have a circle, we will notice that both our x and y terms don't necessarily have to have a coefficient of 1, but they have to have the same coefficient. Because if they had different coefficients, when I divided by the quantity on the right-hand side, like in this example was a 40, then I would get different denominators. If they have the same coefficient, it doesn't have to be anything, it doesn't have to be 1, but it has to be the same, would lead me to a circle. Same coefficients will lead me to a circle. Different coefficients, like this, would lead me to an ellipse. And that all has to do with when I'm either choosing to divide or not to divide by the quantity on the right-hand side. So noticing that difference before you start will let you know whether or not you should divide so that the equation is set equal to 1, or leave it so that the equation is set equal to r squared. One makes them a circle and the other makes it an ellipse. All right, so you've been given a worksheet to complete following this video lesson, and make sure that you log into Schoology as well and follow the entrance slip 4 that you can find in the Unit 9 folder. And make sure that you complete the quiz for accuracy and the worksheet as well. After this lesson, you should be able to complete the square to write a circle or an ellipse in standard graphable form. Please bring all questions to us in class tomorrow.